I saw this integral on YouTube. Now I have a different method to do it. Okay, this one, it's not easy to integrate. So I change this one to integral from 0 to 1 and half pi minus arctangent x2 minus x plus 1 dx. Well, that is obvious to understand that the arctangent 1 over x squared minus 1 plus x, this is an angle. It's an angle, which means this is 1, right? This is x squared minus x plus 1. This over this is this. Now that angle is called arctangent. This over that. So this 1 minus x plus 1. So this is the reason this angle plus that angle is half pi. So that makes sense. And this one is equal to half pi x to 1 minus integral arctangent x squared minus x plus 1 dx. And this one is half pi. I call this integral is j. So we find a j, we find the value required. So let's discuss j separately. There is arctangent x squared minus x plus 1. This integral is still not easy to do. So we may have choices. Use approximation. Here, the Simpson's rule is a good choice. So let me do approximation by using Simpson's rule. Now, first, what I call this x squared minus x plus 1 is f of x. Then the derivative of f with respect to x is 2x minus 1. This is equal to 0, which means x equals to half. That means x half gives a minimum or maximum f. So f of a half is equal to 1/4 plus minus half plus 1. That is equal to 3/4. And this is, I think, is the minimum because of the boundary is equal to 1. That is maximum. This is minimum. Now then, arctangent. Well, arctangent at 1 is same thing at arctangent at 0. This is pi over, because it's arctangent 1. Arctangent 1 is a quarter pi. No, I shouldn't write that way. Let me let me write this way. Arctangent x equal to 1, right, is equal to arctangent x equal to 0. Yeah, that's better. This means a quarter pi. Yeah. That's better. And the arctangent, x is equal to half, right? Which is the arctangent, 3/4. Well, this is arctangent, 0.75. That is equal to 0.6435, approximate. So now we try to use the Simpsons rule. This is x. This is arctangent. X squared minus x plus 1. The vertical axis. So we have 3 points, right? 0 and 1. Special points. 0, 1, and half. And at 0 and 1 is quarter pi. Quarter pi is approximately 7,854. Okay, so this is 0.7854 when x equal to 0 and x equal to 1. The arctangent, that will be equal to, and at the point, at x equal to half, which means arctangent 3/4, which is equal to 0.6435. So this curve is arctangent x squared minus x plus 1. We don't know what curve is exactly is, but we are using a parabola quadratic curve to approximate. So that is the method of Simpson's rule. We try to make a curve approximately replace that curve, this curve. That is the method, Simpson's rule. So this curve, which is a quadratic curve, parabola, we have a second degree polynomial, right? Bx plus c. Yeah, this curve. That means this curve, we are replacing this curve. Okay, then the integral can be done easily. Okay, so let's call this function as t of x. Okay. T of x is this. Is approximately replaced by ax squared plus bx plus c. This is the method of Simpson's rule. Now we have 3 conditions. T of 0 is equal to t of 1, which is equal to 0.7854. So these are given. Well, and the t at 0.75, this is equal to 0.6435 when x equal to this. I'm not purposely choosing the midpoint, but rather the minimum point happen at the x equal to half. It is not my purposely chosen midpoint, but rather, it's a special point is determined just at the midpoint. But Anyhow, it's okay. From these three conditions, we can find A, B, C. A is equal to 0.7568. B is equal to negative 0.7568. C is equal to 0.7854. Well, I suppose you can follow now how to determine these three numbers by using these three conditions. I think it's very easy, just numerical calculations. Therefore, my function, this curve is replaced by 0.7568 x squared minus 0.7568x plus 0.7854. So that is the quadratic curve or parabola replacing this curve. Then our j, this integral, can be replaced by 0.7568 x squared minus 0.7568x plus 0.7854 dx from 0 to 1. So instead of integrating under this curve from 0 to 1, we are integrating this one to replace that. That is much easier to do, and this one is equal to 0.6842. Therefore, my definite integral I is equal to half pi minus 0.6842, approximation. Okay. That is the numerical value approximately equal to the target integral, the definite integral. So this is a Simpson's rule. Well, I hope you can follow. I think this is a very, very good method. Of course, there are tedious calculations there, but well, that's secondary. Well, the idea, I think that the idea is a very good method. Thank you.